A few months ago, maybe even almost a year ago, I made a video about, I drew it on with templates about the glass sky actually creating a false vault. So basically, we are living in the concave Earth, and there's a glass sky at 62 miles high. And I was saying that that glass sky gives the appearance, the illusion, that the sky is actually dome-like or concave looking up, when in reality it's actually convex. And because of the actual angle in which you look through the glass, that actually distorts the sun, the moon. It creates, here I'll show you this. Okay, this animation on the left is looking through an object rotating around the central object, but it's being viewed through refraction. So there's actually a glass, an invisible glass that you don't see is actually it's warping. So you could see how the object, like if this were the sun or the moon, is warping at the extremes, which would be the horizon. And so that is what is actually going on. That's why atmospheric reaction is actually created in the first place. I know that conventional science has it the other way, but if the actual glass sky is causing the atmospheric refraction, and this animation on the left is with no refraction whatsoever. As you can see quite clearly, the object it's going from smaller to bigger. It's revolving around. I'll show you a top view of that animation. Basically, this is what's going on from the top. So this ball is actually just rotating around like that. However, when refraction is turned on, you can't really tell that it's rotating around. It's keeping the same height. And if you notice, when they talk about the moon or the sun illusion, it retains the same size. It's just an illusion because of the foreground elements causing it to appear bigger than it actually is. So that's really what's happening. Here's a schematic I drew in Illustrator, basically, where I explain to you, okay, like if your camera is down here, you're inside the concave Earth, and you're looking at the sun, this would be at the horizon position. It has an increased refractive index because you're looking through. Well, Snell's law says that there's an angle of incidence, but it's going to continue on being parallel. But in the case of the concave Earth, we're actually seeing on a curve. But I just drew it straight for this schematic for you to understand that there's actually a difference in length. If you're looking at the sun, let's say at noontime, there's going to be less refraction, less distortion. It's going to be more spherical, the objects, because the thickness of the glass is actually thinner than it was if you were to be looking at it at the horizon. So it says the glass sky and the angle of view through the glass creates image distortion of the sun and moon and gives the illusion that the sky is vault-like concave when it actually is convex. Objects near horizon are being viewed through longer glass filtration, causing more distortion. Atmospheric refraction. So that's really what's going on. It is the glass sky that's giving you the illusion that the heavens are vault-like, but it's because of the thickness at which and the angle of incidence, which you're looking at the objects, which is causing the distortion, giving you that illusion. So, I think that's all I wanted to say about that.